In this session, we're going to see how to solve absolute value inequalities. And for that, let's recall when we looked at absolute value equations, we started with that the absolute value of either positive or negative 4 is equal to 4. And that led to when we wanted to solve an equation like the absolute value of x is equal to 4, we said that plus or minus x could be equal to 4. But we didn't want the plus or minus with the x, and so we took it and moved it to the right-hand side. And remember, that gave rise to two equations. For one of them, we dropped the absolute value symbols, and for the other one, we dropped the absolute value symbols, and then we used the negative of what was on the right-hand side. For absolute value inequalities, we want to consider just where this negative came from. Now, as you can see, it came from the plus or minus in front of the x, but how did it move to the right-hand side? Via multiplication, or division if you like, by -1. This is essential for understanding what will happen with absolute value inequalities. Suppose we have the absolute value inequality, the absolute value of x is less than 4. Well, in keeping with what we did before, we're going to end up with two inequalities. For the first one, we're going to drop the absolute value symbol and write everything else as is. But for the second one, there's a multiplication by -1 going on behind the scenes. And so when we use the negative of what's on the right-hand side, the inequality symbol itself is going to reverse. This is the key to solving absolute value inequalities. Now, some books will get into and versus or discussions at this point. They'll want you to think about if the absolute value is less than some number, then this is going to be and if the absolute value is greater than some number, then this is going to be or, and I like to ignore that discussion entirely. I have another way of thinking about these things. For our first absolute value inequality, we have x plus 5 in absolute value plus 2 is less than or equal to 10. Now, just as with solving absolute value equations, we're going to solve this inequality by first isolating the absolute value. We end up with x plus 5 in absolute value is less than or equal to 8. And at this point, we're going to write down two inequalities. For one of them, we drop the absolute values entirely and everything else stays the same. X plus 5 is less than or equal to 8. For the other one, we drop the absolute value symbols and use the negative of what's on the right-hand side. The inequality symbol itself will reverse. We have x plus 5 is greater than or equal to -8. We're going to solve each of these as we would any linear inequality. Subtracting 5 from both sides gives me x is less than or equal to 3. And from the second one, I have x is greater than or equal to -13. I'm going to label the number line x. I'll put a -13 and a 3 on my number line. Square brackets because these were non-strict inequalities, and shade in between. Let's think about what this inequality meant to begin with. Once we had it isolated, it was absolute value of x plus 5 is less than or equal to 8. And remember that an absolute value can be thought of as a distance. Here we see that we have a distance is less than some number. Since the distance is contained by some number, I'm not going to end up going all the way out to infinity or anything like that. And this is evident in what we have on the number line. A bunch of values that live between -13 and 3 inclusive. Well, the interval notation for this is going to be just like what we're putting on the number line, square bracket, -13, comma 3, square bracket. And here's my three-part solution to the inequality. Next, we have the absolute value of 9 minus 4x all over 2 is less than 3. Now, my first thought is I want to clear the fraction. My second thought is, am I allowed to? The answer is yes, because here we have a positive 2 in a denominator. I can multiply an absolute value by a positive number without affecting anything. And so on the left-hand side, the 2's divide out. I'm still left with the absolute value. I have 9 minus 4x. On the right-hand side, 3 times 2 is going to give me 6. We're going to split this absolute value inequality into two inequalities just like we did before. 9 minus 4x is less than 6. 9 minus 4x, I'm going to use the negative 6, and for that one, the inequality symbol is going to reverse. I'll subtract 9 from both sides of each inequality, as I would any inequality here. I get negative 4x is less than negative 3 for the first one. I get negative 4x is greater than negative 15 for the second one. And now I'm going to divide. Notice I'm going to divide by a negative 4. And the rules for dividing an inequality by a negative are still going to apply. So I have x on the right-hand side is 3/4, but the less than turns into greater than. For the other inequality, I had negative 4x is greater than negative 15. When I divide both sides by negative 4, we have x on one side, 15/4 on the other, and because I divided by a negative 4, the inequality symbol is going to reverse. Now I want to point out that at these steps, when the inequality symbol is reversed, it had absolutely nothing to do with the fact that these came from absolute value inequalities. Once we split these up into two separate inequalities, these were brand new problems, and the only things that we have are the rules for solving inequalities. Well, on the number line here, which I'm going to label x, I have 3/4 and 15/4. Because these are strict inequalities, I'm going to have parentheses, and x is greater than 3/4, x is less than 15/4, parentheses opening towards each other, shading in between. Interval notation is going to be parentheses 3/4, comma 15/4, end parentheses, and here I have the three-part solution to the inequality, the actual inequalities themselves, the number line, and the interval notation. Here we have our next inequality. The absolute value of 2x minus 5 plus 5 is less than 4. A common mistake I see is people want to take the negative 5 from the inside the absolute value and the plus 5 that's outside and combine them to get 0. We can't do that because the 2x minus 5 is contained in the absolute value symbols. Our path is to isolate the absolute value, in this case by subtracting 5 from both sides, and I get 2x minus 5 is less than negative 1. At this point, I want you to stop and think. Here we have a statement that says an absolute value, which is either 0 or positive by definition, is less than a negative 1. Folks, a positive number can never be less than a negative number. The answer to this is no solution. For our next inequality, we have negative 4 plus the absolute value of 5b minus 2 is greater than or equal to 3. So I'm going to add 4 to both sides to isolate the absolute value. I get 5b minus 2, and absolute value is greater than or equal to 7. Now I want to point two things out. Number one, we want to try to write our b's so they don't look like a 6. Number two, I'm going to cross my 7 so it doesn't look like an inequality symbol. Now that I've isolated the absolute value, and we remember that an absolute value can be thought of as a distance, for this one we have that the distance is greater than 7. Well, how much greater? As far as you want. So that's to me the difference between an absolute value is less than a number and an absolute value is greater than a number. An absolute value is less than a number, you're going to be contained in some small little region. Absolute value is greater than a number, you're going to have intervals that go out to infinity. We're going to write down two inequalities. For one of them, we drop the absolute value symbols and everything else stays the same. 5b minus 2 is greater than or equal to 7. For the other one, we drop the absolute value symbols. We use the negative of what's on the right-hand side. And when I do that, the inequality symbol reverses, so I have 5b minus 2 is less than or equal to negative 7. In each case, I'm going to add 2 to both sides. So I have 5b is greater than or equal to 9, or b is greater than or equal to 9/5. And for the other inequality, I'm going to add 2 to both sides. So I have 5b is less than or equal to negative 5. So b is less than or equal to negative 1. Now we're going to go to our number line. Since our variable is b, I'm going to label it b. I'm going to mark my negative 1 and my 9/5. And if b is greater than or equal to 9/5, that's a square bracket opening to the right, shaded to the right. And if b is less than or equal to negative 1, it's a square bracket opening to the left, shaded to the left. Interval notation is negative infinity to negative 1, parenthesis and infinity, square bracket at negative 1. And then square bracket 9/5, comma, infinity, with again a parenthesis and infinity. Because I have two distinct intervals, I'm going to use a union symbol to connect them. And here I have the solution to the inequality. Here we have the absolute value of negative 5y minus 4 minus 8 is greater than 0. And why don't you try this one on your own? Okay, our first step is going to be to add 8 to both sides. So I have negative 5y minus 4 is greater than 8. And then I'm going to, as we have been, write down two inequalities. For one of them, I'm going to drop the absolute value symbols, write everything else as it is. Negative 5y minus 4 is greater than 8. For the other one, I'm going to drop the absolute value symbols, write down the negative of what's on the right-hand side, and when I use the negative, the inequality symbol reverses. I'll add 4 to both sides in each case. I get negative 5y is greater than 12. And for the other one, negative 5y is less than negative 4. Now at this point, I'm going to be dividing by a negative 5. Because this is an inequality, and I'm dividing by a negative, the inequality symbol is going to reverse, and I have y is less than negative 12/5. For the other inequality, likewise, dividing by a negative, the inequality symbol reverses. I have y is greater than 4/5. I'll label the number line y, because that's the variable of interest. I'll mark my negative 12/5 and my positive 4/5. And y is less than negative 12/5. That's going to be a parenthesis opening to the left, shaded to the left. Y is greater than 4/5, a parenthesis opening to the right, shaded to the right. For interval notation, negative infinity with a parenthesis there, comma negative 12/5 with a parenthesis there, union with parenthesis 4/5, comma infinity. And this is the complete solution to the absolute value inequality. Our last inequality is a lot like a previous example. We have absolute value of 2x minus 5 plus 5 is greater than 4. In the previous example, the greater than had been a less than. Let's see what happens here. When I subtract 5 from both sides, I have absolute value of 2x minus 5 is greater than negative 1. I want you to stop now and think. And what is it that indicates that we should stop and think? Whenever I have an absolute value isolated, and on one side is a negative number, I should stop and see if this is a possibility or if this is a ridiculous statement. In this case, I've got an absolute value is greater than a negative number. Now remember, an absolute value is never negative. It's always positive or 0. And anything that's positive or 0 is necessarily larger than a negative. You can almost think of this as saying this is positive is greater than negative. And since this is always true, our solution is all real numbers.